Welcome back to another episode of Nerding Up with Victor. Today, I'm joined by Vlad A. Ionescu. Welcome, Vlad.
Hey, thanks for having me.
So, yeah, absolutely. Very happy to have you on. We've been trading emails, had a few calls over the last 6 months, and there's a lot of overlap. And the big reason why I wanted to have you on the show and do a bit of a kind of a DevOps, SDLC kind of episode today. And you have good experience in this domain, and I kind of wanted to maybe kick it off there with what you're doing today, and then we can dive into bigger trends in industry. But you are the founder of a company called Earthly, and so maybe we can start off there with a quick intro to Earthly to just kind of level the expectation of the conversations going forward.
Okay, perfect. Yeah. So, hi everyone. I'm Vlad. I'm the CEO of Earthly. We've been building this company over the last 5 years or so. We've been focusing around the area of managing the SDLC ecosystem better. Our first product that we built is a framework to write better CI/CD, and that took off as an open source project. It's now at 11,000 stars on GitHub. It's being used by big companies such as Adobe and Roche and a bunch of other big names like that. And currently, we're building our second product, which is kind of more aligned with like the SDLC and perhaps the supply chain that I know Victor is a big fan of. Our new product called Lunar is about managing the SDLC at scale in big organizations and managing engineering practices in these organizations.
Good stuff. There's a lot to unpack there. So what I find really interesting and is kind of like taking a bigger step at like this whole wave of companies, I guess, that's trying to tackle this CI/CD pipeline. I think it's kind of hard, can't have a really conversation without mentioning Dagger from Solving Ionescu as well. Did something similar in this space, right? And my impression is this is coming from people coming from FAANG largely, looking at what does the state of CI look like for non-FAANG companies. And
yeah.
I believe that's kind of what we started a conversation like a few months back, right? Like this is kind of like your ex-Googler. So is like, maybe like we start there. Like how is the CI pipeline different at FAANG or Google? I mean, I guess you can really speak about Google versus the rest of us, right? Like maybe that's a good starting point to kick this off.
Yeah, exactly. Well, it's a huge difference, right? So if you might have read articles about Google and Facebook and Twitter or X, I guess these days, you might have seen that they have a significant investment in internal developer infrastructure. And I think Google started this trend. They invented this technology called Bazel to basically they started off with a bunch of make files, and those make files were kind of getting unwieldy. They have this massive mono repo where they shove everything, every single programming language, every single piece of code that they write. And initially, it was all managed by a bunch of make files. Now, imagine how quickly that gets out of control, right?
Yeah.
And so, I don't know, maybe 15 years ago or maybe a bit more, they invested in a dedicated internal tool that you might call maybe a CI, but this was pre-Jenkins era, perhaps, right? So it was very early on. And essentially, it's a build system that understands deeply the dependencies between the different components in the organization, right? And it can do a lot of incremental building. It can do remote building, and it can do heavy caching, which is critical for C++ code bases that Google was actually, heavy on. And so a lot of that sort of central type of investment resulted in a very sort of standardized type of developer infrastructure. And that has been actually a massive sort of productivity enhancer for Google. And if you remember back in the day, Google was the hottest thing to work for. Part of that was because they had really, getting that really well. Like the developer infrastructure, making developers happy, productive, and so on. Now, outside of Google, in parallel, something else was happening. Containers were coming along. Google actually internally was kind of, I guess, late or maybe never even took on containers the same way. But containers outside of FAANG in general created a very different type of shift towards heavy microservice use and freedom for each microservice to be defined completely differently in its own specific way, right? And that meant there's more decoupling. That means you can have more freedom within each team to innovate better. But at the same time, that creates massive chaos when it comes to the developer infrastructure, right?
It is decoupling, but also like a really complex mesh of interdependencies that are really hard to test in your CI pipeline, right?
Exactly. Yeah. Testing is just the tip of the iceberg, right? When you think about, how do you insert now compliance, or how do you insert additional verification that maybe individual teams are not thinking about, but at scale, you're now wondering whether every single team is following the proper engineering standards that your organization wants to abide by, right? Whether that's driven by compliance, or, I don't know, maybe protecting your reputation, avoiding incidents in production, preventing security incidents, and so on. All of those things are difficult now to kind of enforce. It's just a big sea of heterogeneous sort of, different things that and basically you no longer have a single insertion point. I think that's the biggest sort of drawback of this sort of movement.
Yeah, and I mean, and the Docker file is almost like the modern Makefile, right? It's of the modern CI pipeline and the dev environment. And
yes,
one of the biggest pain points that I've seen is GitHub Action has become kind of the norm for CI these days, I would argue. And the problem is that you can't run this locally. Like, you can't run GitHub Actions locally, which means that every time you just want to test things as things are running on CI, you need to push the CI. And that kind of like adds a lot of latency when you just want to see if things are working. So that's the other side of this whole wave of new CI tooling, I would say, like CI agnostic tooling that can also run locally. Like, maybe speak a bit about how you see that as well.
Yeah, for sure. The history of CI, I guess, started becoming mainstream with Jenkins. Jenkins was probably the first popular implementation of such a system. I guess it was called Hudson back in the day.
Right.
But over time, we kind of organically grew in this direction where CI and local dev stack are two completely different things, right? Yeah. And that hasn't really changed. And there were some innovations in the field. Perhaps, companies like Circle CI and others have sort of taken Jenkins and made it a SaaS. It's like you no longer have to kind of manage it. It's also much more isolated. Every single job starts from scratch with a completely new blank slate, and so on. And these were good innovations, good sort of steps forward, but we never really integrated the magic of containers into this whole experience. And the beauty of containers is that it runs consistently no matter where you execute it, right? That's a big thing. You kind of isolate its dependencies and so on. And for that reason, we haven't really taken the CI experience to put it on the developer's laptop as well, which is part actually of our mission with our first product. We allow companies to essentially develop their CI/CD pipelines on their laptops and be able to test and execute those CI/CD pipelines on their laptops. And when they're ready, they can push it up to GitHub, and it's pretty much guaranteed that it's going to work because you've run all of that in containers through the magic of Earthly. And we found that to be a good enabler for debugging CI/CD failures, which are oftentimes very difficult to reproduce.
Yes. But
also developing new CI/CD pipelines much faster. You no longer have to wait for like git commit over and over again, do that long cycle like that. And finally, there's something to be said about cross-team collaboration. We mentioned about microservices where every team has its own dev stack, and that means each team has difficulty reproducing the build of the other team. There's perhaps a README in there you have to follow, line by line, configure this file and this other file and so on. Whereas with Earthly, everything is containerized. You just run this one command and everything just works, right? So you never have to kind of wonder how exactly you're going to get this other project set up. And that has been very powerful for our open source users.
Yeah, and I think, this, as CI's evolved, like if you go back into the days of like early day Jenkins, right? CI was just a bash executor, right? That was like, you just ran a bunch of shell scripts in like a sequence. That's no longer true. Like look at a modern CI pipeline on GitHub. Like you have GitHub Actions module, you do this, you do that, you pull in caching from here. Like it's so much more complex than way back when. Like you're not dealing with like a DSL essentially. Like it's almost a DSL, right?
Exactly. I think in many ways, some of the same basic concepts have remained similar, right? So like, yeah, now we write in YAML. It's no longer exactly like a bash sort of, line by line execute this and execute that. And yeah, we have caching, although I would argue that caching is still kind of rudimentary. And we found that, if you actually invest in understanding the dependencies between projects and you have a system that really can leverage that heavily, you can get to like 10x faster CI builds just by doing that, right? And that's part of what Earthly actually also delivers. The other thing I've seen in recent CI sort of environments is that there is use of plugins, right? That's kind of natural. And recently there was this vulnerability in change files, right?
Yes.
And before that, some years ago, there was CodeCov, right? Things that you put in your CI, and there's very little governance around. Like people care a lot about what you put in production, but maybe aren't so careful about what they're putting in their CI, right? There's no SBOM for CI/CD, right? Or there is, but people don't adopt it.
Funny enough, there is a conversation I read this week actually on the SysML list about actually defining this stuff. Like before, I think they call it a P-bomb, like a pipeline bomb, essentially. But
Right.
you're absolutely correct, right? In particular, in the world we live in with Cursor, that I would imagine Cursor is probably writing a lot of the GitHub action files these days, and it's just like, write me this pipeline, and it just pulls in various modules. And one of the first thing I always do is like, okay, cool, but do we need this, or can we actually do it ourselves? That is the first thing, right? And also like, and if we do need it, what's the security track record? Like, how many? Even if you use like something very, very rudimentary, like how many GitHub stars does this have? Like obviously in the case of changelog, perhaps not very good as a proxy, but at least is a proxy rather than projects out there with like 5 stars on GitHub that we have no audit trail on at all.
Right? Oh yeah. even the more popular ones, we've seen some really low level stuff that is extremely popular, basically ubiquitous. And, after many, many years of exposure, we just figured out, there was a vulnerability here all along, right? And you don't know what kind of like state-funded, foreign government has been leveraging that all along, or you just don't know. It's kind of like this big unknown sort of risk you're kind of taking.
Yeah, and that's it, right? Like there are so many levels of abstraction involved, right? So like if you look at the anatomy of one of these modules, like it's the basic GitHub module, like it's probably, let's say, for instance, written in Ruby, in NPM, like in JavaScript, right? Like, we're probably pulling in like 50 or 150 different dependencies, which in turn all might have their own vulnerability track record, right? So it's such a complex space to do proper security audits on, right? You kind of need, like, not only do you need to pin the module you're using, like I know, OpenSF got some tools around this for like pinning a hash against the version and all that stuff, right? And that's great. But you also need corresponding like an SBOM essentially against that hash. So you can also say, okay, cool, this has this, but also this actually is included in there. So if there is a CV in there, you can actually find this. But that's, now it becomes such a tremendously complex problem to just run your CI.
Yeah, exactly. And especially that we want to insert all of the security verification in CI/CD when perhaps, the goal of each individual application team is to ship features and not to kind of be held back by security scanners and all that. And I think that's where there is a bit of misunderstanding between central teams like platform and security and so on, and the individual feature or application teams. I think in that regard, a lot of times the responsibility of owning the CI/CD pipeline is kind of shared, right? So like the platform team or the security team wants to insert a security tool, and the application team doesn't even acknowledge the PR whatsoever. They're just, full steam ahead. We have to ship this or whatever.
Yeah.
Right. And we've heard from companies, we were doing this industry research last year, like sometimes it takes like a year for PRs that are submitted by the central teams to get merged into all of the projects. It's like the long tail is insane. And all that time you're kind of exposed and don't even know what exactly your posture is all around your organization. We found that to be a big issue because there's like individual tools to kind of extract test bombs for different types of languages, containers, and you kind of skin the cat in so many ways. But currently, there are no good tools out there to understand whether those tools have actually been implemented everywhere within the organization. One thing, right? And the other thing is, how do we make this shared CI/CD pipeline have clearer boundaries about who owns what? Perhaps the platform team does need to own some piece of that to be able to insert verification, right?
Yeah, and there's also like not all CI runs are equal either, right? Because if the attack vectors are different, right? If you have a run that just does something to your checked out code base and doesn't actually write anything back or ship any artifacts or ship any binaries or ship anything, like the blast radius that is pretty slim, right? Sure, you could do something nasty. Maybe you can leak the secrets. Okay, sure, that's bad, but it's not gonna have any significant security issues on your actually what you actually ship into your customers, 100%. Right? So that's another element that is so much more complex in this pipeline because you can't it's hard to, I guess, programmatically detect that in the pipeline what it does.
Yeah, exactly. So you touched on a great point here. A lot of the companies that need to insert this very strict type of verification oftentimes invest in central CI/CD templates. And so every project would have to import that. And that means you're going to get all or nothing. You either import that and you're going to get like the whole shebang of security verification, and it's going to be extremely restrictive, even though maybe like you're saying, right, your application might not be even talking to the internet. Maybe it's not even handling any user data. It might be just an internal thing, right? Maybe not shipping anything at all. And in that regard, you need a way to create scope for what you care about, right? Have a definition of scope. What's in scope for this type of compliance? What's in scope for, handling PII? What's in scope for things that are exposed to the internet and so on? And all of these different things you probably want to treat differently because you want to have as much agility as possible in general. But for the things that are more sensitive, you can afford to kind of insert that scanner. Maybe it takes 20 extra minutes of your, CI time or whatever. But you have to kind of treat these differently.
Yeah. It's such a complex thing to apply this blueprint across all these things because I guess the benefit with the old style CI where everything was a bash script was that there was limited attack vectors in that sense, right? Like there were like fewer things that were easier to audit, I guess, in many ways, right? But now we have this level of abstraction. You have like the CI modules that you're calling on. You have Docker files that you need to be audited. You have there are so many possible attack vectors, and not only that, like how do you even audit that, right? Like what version? Like are you running an EUL Docker container with I don't know, like a node version that's EUL, right?
Right. Yes.
It's so complicated, right? So how do you how are you approaching this as a problem space?
Yeah, the way we've been the mantra we've been operating on with this new product has been, there's a lot of monitoring that goes in production. You have logs, you have metrics, you have instrumentation, you have alerts and firewalls and policies and so on.
Yeah.
But there's nothing like that for the SDLC, the stuff that happens before production. And that has been our sort of guiding light towards what we're building here. We're basically building monitoring for SDLC. And what does that mean, right? You have to understand what exactly is being built and how it is being built throughout your SDLC. And like I mentioned, there's that high degree of diversity within each project. You want to be able to insert centrally this kind of verification without having to integrate with individual projects one at a time, where you're depending upon each team to adopt your templates or your additional gates or whatnot. You need to have independent control of some of these general gates and be able to kind of select, I want to apply these to the services that are in scope for this compliance versus I want to enforce these things in this other way for, things that maybe have different kinds of requirements from the compliance or security perspective. And having this ability to insert in a single spot and create a system of record of the posture of each application. And when I mean system of record, I mean things like, is your application properly tested? Is your application, using the right security scanners? Is your application perhaps handling this kind of data or in scope for this other compliance and so on? And all of this sort of posture information can then be used as a way to monitor things. How is code coverage, deviating over time and so on? Or are you handling your vulnerabilities within the right time frame? I believe for many compliances is like 30 days for critical vulnerabilities, for example. And then you can create policies based on these things. You can say things like, if your code coverage is not, 80% or whatever, initially I'm going to monitor it, but over time I might even enforce it and give you feedback in your PR. So as soon as you open a PR and affect your code coverage, I will block your PR and be able to kind of insert myself as a platform team without ever having to edit your CI/CD.
Yeah, so I've heard of people doing similar things with I know there are banks out there who are using like dependency track, for instance, to do like audit on SBOMs, and then they tie that into their policy agents and say, oh, if you have any CVs, block the deployment, right?
Yes.
But that's also a little bit flawed because what if you already had that vulnerability and now you're improving the posture, but you're still blocking the improvement, right? It gets a little bit tricky, right?
Exactly. You need what we call gradual enforcement. And that is like each control you want to enforce has to be treated differently. And we have like different levels. So for example, you could initially just monitor things, whether they're, in a good state or not, and perhaps use offline sort of, I would call it an offline sort of campaigns where you kind of advocate for this new practice within the engineering teams, send them GitHub issues, send them Jira tickets and whatnot, and get the percentage higher and higher. And then when it's close to 100% or maybe 80, 90%, you announce that you're going to start blocking PRs, right? And maybe after you start blocking PRs, then the next step is perhaps blocking production. But sometimes especially in the security space, there's going to be false positives, and you want to be careful with blocking things unnecessarily. So some things will forever stay in this mode where you kind of monitor things, but not necessarily strictly enforce them. And you kind of couple that with the security team helping out triage all the false positives and all that. But we've seen this. It's hard to have a hard and fast rule for everything, and you need the flexibility to be able to say, these policies I want to be very strict about because I know they're going to cause incidents. Whereas the other policies, I want to be more flexible because they could be false positives and such.
Right. There's a lot to unpack there. So the one thing that I'm curious about how you're approaching is the whole like problem of building, right? Because like, how do you monitor a build? Because you essentially, in order to do it properly, you kind of need to monitor every single request that your build does outbound, right? You need to have like a firewall, like, oh, you spoke to like, oh, you're building a Debian package, but instead of pulling that, you pulled in something completely random where you're like making random requests, right?
Yes.
Is that part of your pipeline as well? Or like how granular in your access control do you get there?
Yeah. So the way Lunar works is that we have a CI/CD agent. That is one of our insertion points. The other insertion point is that the code level doesn't depend on the CI/CD.
Right.
But I think this pertains specifically to CI/CD. So in CI/CD, the agent monitors every single pipeline that runs in your organization. It runs alongside the CI runner. So if you run, GitHub Actions on-prem, for example, we run alongside that agent essentially. And by understanding everything that runs in every single CI pipeline, we can see the types of processes that you execute. And we allow the user to say things like, every time I see MVN test being executed, I'm going to look for JUnit XML and put that in my metadata and collect that. And maybe I have policies around some testing, for example, right? So it's that level of instrumentation where we look at the syscalls that are being made and are able to be very precise with extracting information from the right places. Now, and there's a collection of plugins that make this easier. Now, when it comes to network traffic, that oftentimes is more difficult. You can create, you can see what IPs are being accessed, but a lot of times that can be very noisy when you try to kind of create a an allow list or a block list based on that. And what you can do instead is perhaps making sure that the different tools that are being used are configured to use the right artifactory or image registry and so on. That tends to be a bit like better from like the the precision of it.
Alternatively, like you almost have to run everything through like a SOX proxy or something like a transparent proxy of sorts, so you can actually like get what are you actually pulling down.
Exactly. Right? That tends to be much better. So like you might have a kind of like isolated network, and then you kind of know that you want to block, I don't know, Maven Central, because you have your own mirror that has been kind of blessed internally.
Right.
And that tends to be like a very effective strategy. It kind of slows down teams, because if they need like a net new dependency, they have to go through channels to kind of get it approved and everything. If you're really big on security for whatever reason, you might be like a highly regulated industry and so on, that tends to be probably worth it for those kinds of organizations.
Yeah, I had Steve Springett on the show quite a few episodes ago talking about these as an attack vector for well, he was talking about it for SBOMs, but one of the interesting attack vectors there is like if you're using like private namespaces for private packages, and then you have name squashing attacks essentially in the public space, right? So if you know that Salesforce is using this internal package name, but then you go and register that in whatever the artifact, whatever the registry is that they're pulling, like NPM or whatever, and then you can infiltrate that and just like have a rogue version of the same thing. So that's an argument for having some kind of proxy that sits in between, right?
Exactly. That sounds super dangerous. And I mean, somebody's going to run that thing, that NPM install with no authentication by accident, and he's going to pull the wrong thing from the internet, right?
It's just one environmental, you forgot to define some environment variable, and now you pull it from the internet rather than from your self-defined one, right?
Exactly. Yeah, that's very nasty. It's hard to protect against everything, right?
I mean, you kind of need to have this, like in particular it's annoying because you're adding friction, right? Like one of the big upsides with the container revolution, if you call it, right, was that it brought back autonomy to the teams. They're like, oh, we want to use this, we want to use that. But now we kind of come in full circle. Actually, you probably shouldn't have done that because you actually didn't know the ramifications for doing that. You just want to solve the problem as quickly as possible.
Exactly. Yeah. There is such cases where oftentimes you can enforce for dependencies to be clearly, like explicitly named so that it can only match the internal private one, right?
Yeah.
That it might not be obvious to enforce, but it is one of the things that we focus on as well. Like if you have any custom verification, we allow you to write like a central, I would call it kind of like a global CI. It's like a definition of a set of bash instructions that apply to every single repository. And you can use that to collect information about them. So you might collect information about, okay, are you using, this dependency by its, ambiguous name or by the very specific private name? And then you can sort of enforce that through Lunar. We've seen people come up with extremely custom and very specific, things they want to add to their enforcement based on perhaps past postmortems, based on, public incidents, or based on just their engineering culture. And I think this kind of flexibility is kind of difficult to define in traditional CI/CD pipelines. You kind of need something that's sort of runs beside it. It's dedicated to a different sort of purpose.
Yeah, and I mean, it's going back a little bit to the whole point of like the difference between the FAANG of the world. Like they have internal tooling that can give you the best of both worlds almost, right? They can provide all these guardrails without slowing down development, but most companies cannot do that, right? That's not realistic for more small to medium teams or even enterprise teams, right? They don't have their tooling for this, right?
Yes, exactly. And every company's culture is just very different. The way they've the rules of how they deploy to production, and the different conventions they use internally. It's hard to have a one size fits all, especially when like you have 10 microservices and every now and then one of those 10 microservices is going to be like the weird one, like it's going to have its own sort of deployment way and like its own way to I don't know, extract dependencies or whatnot.
Well, yeah, it just depends. Like, oh, this is an old application, we haven't upgraded, we know it's end of life, but we have no resources to actually update this, right?
Exactly.
Either because it's an external vendor that's sunsetted it, or you just don't have the engineering resource internally to do it.
Yeah, exactly. And that is sort of manageable when it's like the one odd out, when you have like 10, 20, 30 microservices. But when you start to have like, I don't know, 70, 100, 200 microservices, that's where, like something being weird is actually the norm. There's always something weird in your infrastructure. And that means you're going to have less ways to enforce proper engineering practices, basically, and security and all that.
Yeah, I mean, I had a Dustin Kirkland from ChainGuard on a few episodes ago, and we talked about the whole thing of like rolling versus stable releases, which is kind of a tangential problem space here, which, and he's a big fan, obviously, of rolling releases, and like you deprecate things as they get deprecated, which is absolutely best engineering practices. I don't think anybody can make an argument against that. Well, I'm sure people can, but like rationally is very sensible. But it does create that problem of like, it's great if you have a good team with good culture, with good velocity, and you can just like, oh, let's fix it up. But many, if not most, engineering teams do not operate like that, right?
Yeah, exactly. Yeah, that's a great example. And I think I watched that episode, and he was saying like, okay, but now you have to upgrade things, but that's fine. It's like, I forgot the analogy, but it sounded like, it's either you break your legs and,
it's
or
stub
like,
your toe, break your leg, or think something like that, right?
Stub your toe, break your legs. Yeah, exactly.
Yeah. And it's spot on, right? But like the reality is that a lot of these decisions are kind of held on a higher level. Like, a lot of this is a cultural problem, more so than a technical problem in many ways, right? It's just like, the budget is to shipping new features, not to maintain what we have. That's how most companies operate.
Exactly. Yeah. Whereas some teams may be more like, like a library team or whatnot, and they have to support the use of that library for many different applications in different ways. And the decision might be different. So like, having this freedom to create your own engineering process is both good that, you can use the right tools for your job, the right practices, and so on. It does come with its downsides, and you kind of need to have a good plan around, managing those downsides.
Yeah, it's this constant like battle, and you kind of need to not stop it. At Squeedly, we do what we call system and tools week. So we do 2-week sprints and then 1 week system and tools, where that week is earmarked, generally speaking, towards like improving our internal tooling. And you kind of need this time budget, essentially, generally speaking, because if you just jump from sprint to sprint, and in small to mid-sized team, you're never going to get around to fix these problems.
Right. Yes.
So
yeah.
All right. So let's switch gear a little bit to culture, because I think that's something you spent a lot of time on, engineering management and culture, which is kind of like, well, I guess is a good segue over to that from that. And we're both fans of remote teams and building and scaling remote teams. So maybe let's kick it off there. Like, what have you learned over the years building and managing engineering teams? Like, I'm really curious about your input and your thinking around that, and what you've learned over the years.
Yeah, and I should preface this by saying that I've managed startup engineering teams, which is perhaps a bit different than FAANG type of teams, right?
Oh, absolutely, yeah.
Right, but I think one of the key decisions as a startup is, how do you find talent that is extremely effective and doesn't burn your runway, too fast? And as a startup founder, you oftentimes, it's not as critical these days, but you oftentimes have to be in the Silicon Valley area to kind of have access to the investors. For whatever reason, they see that as a benefit, like a dedication, your commitment and whatever.
I would say it used to be more so 15 years ago or 20 years ago than today, I would argue. But yeah.
100%. Ever since COVID, I think even that has changed dramatically. Yeah. But I happen to be here in the Bay Area, and hiring here in the Bay Area is like extremely difficult. Like these total compensation packages are wild, especially when there's the companies they work for have a certain stock that has been growing for the last few years. It's not unheard of to have like 500K sort of total compensation
like I think
packages.
like if you're, I saw somebody done a comparison like on I think it was like level 6 engineer at Facebook is like total comp is like $1 million or something like that, north of $1 million. And
Crazy,
it's just like
yeah.
you can't compete with that as a normal company. That's just impossible.
Exactly, yeah. I mean, imagine seed stage startup might have raised, I don't know, like say $6-7 million. Like does that mean for 2 years running where I'm going to just afford 3 engineers? That cannot be, right?
No, right, exactly.
So marrying that sort of requirement of having high talent but doesn't break the bank type of thing. At my previous company at Shift Left, nowadays called Quiet.ai, I led the engineering team, and I with my colleague, the CTO, we built a team from scratch, and we looked internationally mostly, right? We looked one of the centers that we found, our chief scientist and actually the person who ended up creating most of our secret sauce, if you will. We were able to hire in Germany.
Okay. That's an odd choice. That's not something you normally hear. Like usually people stay away from Germany because they have very, very tight labor laws, and it's just very difficult to hire there.
That's true. I think it was not necessarily our top choice because of what you're saying, but also this person was in Germany, and actually it worked out really well for us. And so we built a team around this person in Germany. And we also hired like about a third of our team was fully remote. So there were people from like New Zealand or Argentina or Brazil and so on. And perhaps one of the things I learned early on was that this sort of time zone scattering is extremely difficult to manage. Even us, the central office here in the Bay Area versus Germany, the time never overlapped, right? So somebody had to make a compromise to be able to get on a simple meeting, right? They had to stay, up later, or we had to kind of get up earlier. And that created echo chambers. We were not aligned from like the product standpoint in some ways. You kind of have to find ways to work around that and be able to collaborate better. So this time around, as I built the new engineering team here at Earthly, I knew that we had to go remote because of that sort of cost aspect, but at the same time, maintain roughly the same time zones. Right. And the prices for engineers are not as good here, sort of in this time zone as they are in Europe. Basically, in Europe, you get half price essentially, which is like crazy, right?
Sounds right. Yeah, sounds about right. Yeah.
Whereas here, you still have to pay, significant amount of money for the top talent, but it allowed us to be within the same time zone. Especially in a startup where the product definition evolves very, very quickly, you have to be constantly in sync with the engineers. And I think that's key. I think if you want to manage a remote team, you have to have a very stable and very well-defined API between that team and the rest of engineering. So, for example, a great example I've seen at another company was they had the payments team in Turkey, for example, right? Then payments is kind of like, okay, you have to kind of swipe a credit card. You just have to support all these different countries and integrate with Stripe and a bunch of other vendors and so on.
Yeah.
But it's kind of like a well-known entity. It doesn't have like dynamic product requirements. And I think that tends to work really well if you can have that sort of API between teams. Otherwise, I personally prefer to kind of have teams centralized from the time zone perspective, but also we're embracing the full remote culture. And when you embrace the full remote culture, you also have to have frequent offsites. You have to kind of get together frequently and be able to kind of get on the same page. Sometimes our thinking and ideas deviate over time, even if you have like daily stand-ups or weekly stand-ups or whatnot. And that kind of helps get everyone on the same page and sort of revitalize the energy of the team and so on.
100%, I agree with the offsites. We when we started doing that about almost a decade ago, like the culture shift was so phenomenally different. Like it's just so different to having to interact with somebody, even if it's a video call, versus sitting down, having a beer with somebody. Like you get to know people at a completely different resolution, right? You understand like the nuances, and that helps smoothen things over a lot more when you go back to a video call once you've had those face-to-face interactions, right?
Exactly. And the key thing is building trust, right? It's a bit harder when you're a remote team. You have to rely heavily on async type of communication, written documents and all that. And that trust element is sometimes lost in the communication there, because you're brief, you're like you kind of directly say what works, doesn't work, or what things to be different, and people might perceive that negatively or like adversarial, if you will, right?
Yeah.
Whereas in person, there's more nuance, there's more I'm a big fan of team bonding. So like one of the first things we do in offsites is just spend the day hanging out, doing non-work stuff. We actually put that as the first day, the fun day.
It's funny because a friend of mine reached out because they were doing the first first offsite for his new company, and he was asking me like what my experience was like. And actually, very much to your point, to me, the first day is a write-off because it's just obviously we travel all that depending on how many time zones, but beyond that, it's about getting together and just like even as a manager, like or leader, see how the dynamics happen organically within a team. That's super important as well, and see how other people, how the teams interface with each other as well.
Yes, exactly.
That was like one of my first, like, make sure it's at least 3 days, because less than that is just pointless, in my opinion.
Yep.
And first day and last day, write-offs, because like first day of arrival, people are tired, people have been up early, like it's not going to be a productive day. Last day of travel, same thing. Like people can get ready for the airport, people have different flights. At least 3 days would be 1 day of actual productivity.
Exactly. And like being locked in a single room for, I don't know, 8 hours in that single day is also exhausting. So you kind of want to use that energy with a lot of intentionality, I guess.
Yeah, 100%. So there's a lot of like, I guess, definitions around these like remote first, remote hybrid, all those stuff, right? And now, obviously, now we get to see the boomer way back to the office and all that stuff. But that's a whole different conversation. But I guess you guys are not really remote first because you do have an office as well, or do you consider yourself entirely remote first?
No, actually, at this new company, we no longer have any office, and we never had an office. We started at my previous company. We were hybrid, right?
Okay.
And perhaps this other lesson is hybrid is actually much more difficult than fully remote.
Yes,
because there's going to be like people talking in the office about certain things in person, making decisions, moving fast, and then the rest of the team is like, okay, but wait, what happened? We talked about this other thing last week. You have to now catch me up or whatever. They're
so much
always left behind.
We've coined the phrase, it's the water cooler effect, right? Where it's informal communication that happens in an office. So we try to mimic that in Slack, essentially, like have a water cooler. Like sometimes it works, sometimes it doesn't, but it's like, it's not quite work, but it's stuff that would happen in a regular work environment, right?
Yeah. Exactly. There's a trick for, we use this, you have like a little schedule, like a rotation. Every person asks an interesting question per day in the water cooler channel. And we found that sparks like interesting conversation that would otherwise not happen. Because otherwise we're kind of focused on work and like, nobody wants to talk about, I don't know, cats or whatever. But like, if you ask like informal questions that are about something fun, and every team member comes with something every day, it creates much more sort of engaging conversation. It's not necessarily about catching up on work or anything. It doesn't necessarily solve that problem, but it solves a little bit of the trust problem that perhaps is often missing in async communication.
I mean, trust is such a important piece here. Like I wrote a blog post that made its way to Hacker News a while ago about a decade of remote work. So I basically captured what I've learned over doing like remote work for a decade. But one of the biggest things is kind of what we touched on. The first one being either you go all remote or you all in office. I think hybrid is kind of like an illusion because
Yeah,
it's just
exactly.
this particular about documentation. It's a big one. Like, how do you document things? Like, if you're a remote first company, and obviously there are plenty of good examples, GitLab being one of the good ones about this, right?
Yep,
Then
yep.
you have a documentation culture is different. Whereas if you're a kind of an office-based company, there are a lot of like unofficial ways and like wisdom like are spread by asking people and
Yeah,
walking over to their desks, right?
yeah,
Um,
yeah, yeah. It can get a bit political too, because like you know this person better than this other person, and you're gonna
yes,
talk with that person about the requirements or the goals and whatnot much more than this other person. So like there is like subtle ways in which you accidentally empower more people differently across the team.
yeah.
Um, Plus, I think there's with this new RTO return to office sort of thing that's going on right now. I feel like companies are the norm is now hybrid, which is kind of bad, right?
I
It's
mean,
like 3 days
honestly,
per
like
week in the office and so on. It's like somewhere in
honestly,
between.
the RTO thing is just a big mass firing in disguise. That's really what it is.
Right. Yeah.
That's
That
all
too.
it is to
Yes.
it. It's
Yes.
not like, yeah, I don't believe in it. I think it's just people want an easy way to weed out the people who are not as dedicated, and that's just not to policy. It's like, okay, cool. 20% of people don't want to
Yes.
come back. Cool, fired, done.
Yeah. 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 The sad thing about it is like a lot of times you're gonna weed out the people that perhaps have kids or such. So
Yeah.
like it's a bit of discrimination in disguise. It's you can't really put your finger on it, but it is gonna sort of affect different people differently because of that.
Oh man, there's no way I'd have a desk job where I had to go and commute in every day. Like, no way. I would never do it. Like,
Yeah,
I've done remote now for like what 15 plus years. Like, there's no way I'm
yeah,
going to allocate an hour plus a day commuting. Like, there's no way.
yeah.
Like, it's just there are way better way to spend that time. So
Exactly,
absolutely.
exactly.
Um,
Yes.
the other thing you mentioned that I have the same kind of observation as you have is trust in when it comes to remote, right? The trust is so difficult, but it's kind of like the holy grail of remote because if there's no trust, like things, there are a lot of cultural implications of that, right? There are a lot of things, but speak to me
Hmm.
about how you view this and how you've kind of building accountability and like as part of this because remote is difficult, right? Because
Yeah,
yeah, the one
exactly.
thing you could say about an office is like, oh yeah, you showed up, cool, but you can't
Yeah.
quite say that about somebody working remotely and
Oh
plenty of
yeah.
horror stories, right?
Oh yeah. Like how do you measure people and make sure that they're actually at work, right?
Yes.
And there've been so many bad takes on this, like spying on employees' computers, making
Yeah.
sure they're like moving their mouse or whatever. You
Yeah.
know,
Yeah.
I think that's bad, right? If
100%.
if you get to that point where you have no idea if your employees are productive, you're not measuring your employees properly, right? You should be measuring them on output, not on activity. And
Yeah. That's so much
yeah,
so true, right? Because like one of the things that I'm fully on board with is like if my people are working remotely, I'm okay with them going and doing things where it makes sense. If they want to go and get their haircut at like 2 p.m. on a Wednesday and they have no other meetings, like go ahead. Like why
yeah,
not? That's fine. I don't care. Like
yeah,
just as long as you
exactly.
get your stuff done, right? Whatever.
Yeah, and the way I've also talked to remote teams about this is that, um, hey, you can take your kid to daycare, do your haircut, go shopping, whatever you need to
Yeah.
be flexible. And occasionally we will ask for you to be flexible for us, an incident on
Yes.
the weekend and whatnot.
Two-way street.
So exactly, we don't typically ask that many times, but um, I think everyone would prefer if that were the case more frequently than not, right? Um,
Mm.
I started my career actually in back in Romania, where post-communist country, perhaps the culture was much more based on measuring activity as opposed to output, kind of like you would do
Yeah.
in
Yeah. Low
communism
trust.
regimes. Exactly, low
Yeah.
trust and all that. And so I just took it for granted initially. Oh, it's 9 to 5. I really have to be. If I'm late by 5 minutes, I have to kind of put that in the system and all that. I now found it extremely ridiculous that many companies have just continued that way, not just in Romania, but in the Western world a lot as well, right?
But I think that's a boomer mindset, right? It's like, oh, but in the desk, but like in the chair at the desk. Like that's more
Right.
important than what you get as output, right?
Yeah, perhaps. Exactly. And I think there is something to be said about hiring the right middle management and lower management teams, right? If those teams are unable to properly measure the output of their employees, that's a much bigger problem than your ICs not working or not being able to trust them, right? So I'm a fan of hiring people that are self-sufficient, that they can be the kind of like the CEO of their own jobs, right? And trust them completely on what they execute on, and work with them sort of on results and outcomes and such, as opposed to the nuts and bolts of like where was your butt in the seat at this time and whatnot.
Yeah, this is interesting, right? Like, and have you? Is there any framework that you adhere to in terms of like quantifying these things that you found working better than others?
We don't have like a very formal framework, and I think that would be kind of natural for a small company like ours. I think at scale, you probably need some sort of framework, but it's probably similar to career ladders and such. You typically have performance reviews, and you measure people based on what they were able to achieve and such. I think those are great on their own for the measurement of, was this employee present at work, sort of from the execution standpoint, and less so, other sort of information. I've seen big companies though insert things like badging data and computer activity data in their performance review. I think that's kind of backwards.
Yeah,
I don't really believe
I'd
in
agree
that.
with that. There's a framework that I kind of like, which is entrepreneurial operating system. They have like three very simple questions for like performance reviews. It's funny because I was literally working on this today, so it's just fresh in mind. But they have like, can you do it? Do you have the capacity to do it? And do you want to do it? Those are like the three main questions. Like if you can like, those are good determinations of like, is this a good fit for the role? And if you're actually delivering it.
Yeah.
It's very distilled down to simple. Yeah.
That makes a lot of sense. I think those three questions are probably the best balance. You don't want to create like, a review system that takes everybody offline for a whole week or something. And you still want the data from it. You kind of have to balance the sort of precision and number of questions and all that.
Absolutely. Is there one lesson that you would say for somebody who's new to managing a remote engineering team that they need to get? Like, what's the one advice you would give them?
Great question. I would say I can think of two or three here. So one, sure. I kind of already mentioned, which is think about time zones and how your teams are going to collaborate, right? I think that's critical. The other part of it is perhaps the how do you work together and managing the async sort of communication style and being fully bought into that style. Like default to documenting decisions, default to reviewing design documents, default to relying on GitHub comments and Slack messages as opposed to word of mouth and such. And this is kind of like a muscle. You have to, maybe it's a bit unintuitive for someone who's new to this, but if you trust a few official tools, I think that's also important. Don't use both Notion and Drive and so on. You have to kind of standardize on a limited set of tools, and then any communication that goes through that tool is just as official as any other channel, right? And investing deeply in that is really important. So I think that's perhaps my top two sort of takes on remote work.
Fair enough. All right, let's switch a bit more gear to something that is kind of more back to your story before, which is AI in the pipeline, I guess, and more specifically in the SDLC, really. And I'm curious about your take on that. Like, I foresee a world where AI will write code and AI will review code, and then we have agents talking to agents, and then there's probably some human in the loop somewhere to review and make sure that nothing crazy is going on. But talk to me more about how you see that shifting, given that you are deep inside the SDLC world, really.
Yeah, there's a few ways this could go towards, right? And I think it's hard to really predict the future. But I can think of the far future type of system is where they're no longer software engineers. They're more like PMs writing prompts, right? And iterating with a system. And it's sort of all taken care of behind the scenes. Perhaps in such an environment, there's more reason to standardize the tech stack. Like if the AI is going to write everything, why not write it in a single programming language? And maybe it's like extremely geared towards AI type of workloads. So maybe it's still transparent so you can see and audit the logic behind the scenes and so on. So it's still human readable, but it's not as necessarily as diverse. So that's one possible option. I think in the short and medium term, there's going to be a lot of hybrid work between human and machine, if you will. And in this hybrid work, kind of like with self-driving cars, the problem would be so much easier if there were no humans on the street, right? You couldn't 100%. Have like beacons and
we have no like car accidents.
Exactly, yeah. And like the uncertainty of it all just goes away tremendously, right? And that is kind of similar with AI, right? You still have to rely a lot on human engineers, and this might be the norm for a very long time. For all we know, we have no idea how fast it's going to evolve, right? And in this short and medium sort of time span, we probably need to treat computers with the same care as sort of an engineer to some extent. So either that way, you say like an AI agent is an engineer, and you apply the same principles. Somebody has to review their code. You have to scan their stuff for vulnerabilities. You have to enforce engineering standards and so on. And so that's one way to see it. Or perhaps the AI is like an extension of the human, and everything the human authors is with the help of AI. I think that is where we are right now, right? Yeah. And the human might be a little bit sometimes careless about what the AI introduces. And for that reason, you need even more verification on top to make sure that no strange things have been introduced, no vulnerabilities have been sort of added to the code base. Maybe whatever training the AI had was a bit out of date and using old dependencies or whatnot. You want to make sure. Exactly, right? You want to make sure you're not sort of behind the curve of the what security today is in terms of dependencies and all that, or engineering practices that are specific to your company. So I think in the short term, there's much bigger need for this kind of guardrails and verification and making sure everything is abiding according to engineering standards and security standards that you want to enforce in your organization. So yeah, I think over time we're kind of learning as an industry how to manage all this, but definitely it's a huge shift that is perhaps changing our mindsets, the way we think about SDLC and all that.
Yeah, I mean, I'm a big subscriber of your first vision, right? I think engineers will essentially become managers of AI agents, right? And then, but this is the important part, because I'm sure you saw this broke this week as we're recording on Twitter. This guy who wrote some SaaS product, and that is like, oh, holy shit, people are injecting stuff into my database, they're bypassing payment. I have no idea what my code base does. And it's like, he was a non-engineer who written some piece of software using Cursor essentially, or the likes of Cursor, right? And it's just like, there is a scenario where we will have these AIs who can write good enough code autonomously that a non-engineer can manage. But I think that's pretty far out, right?
It is. And going at it with a naive mindset. Like I imagine a non-technical CEO is going to assume, okay, we have to kind of heavily rely on AI now to be efficient.
Yeah.
And they're going to just create a lot of chaos, because like that AI is going to write stuff that is pretty much a black box for everyone else. And it's going to be riddled with vulnerabilities and issues
like
and
duplicated
whatnot.
Code, no logic, complete. Because I mean, that's the funny thing. Like, if you think about it logically, it's probably cheaper for an LLM to write new code than to maintain existing code.
Oh yeah, 100%. Yes.
So it will.
It's true for humans too,
anything,
right?
It's just going to duplicate everything like a third time, right?
Yes. Yes. Exactly. Yeah.
So I had this conversation with some friends a few weeks ago, and I'm basically like, my big bet is that in the next 12 months, we're going to have a lot of these companies that manage to build a product, manage to capture revenue, and then they realize they have no idea how the product is written, what it does behind the scenes. It's completely a black box, to your point. And then they're gonna be in for a world of pain. And there are probably gonna be a lot of people who are gonna make a lot of money trying to salvage the disaster that is their code base.
Oh yeah, exactly. And catching up from that, you're just kind of digging a hole for yourself, and getting out of that hole is going to be very expensive at the end of the day. Like the original goal might have been to save money, but you know what? It's not actually going to work out that way in the long term.
No, I mean, there's an argument that is that, well, these products would have not existed otherwise, so therefore it's a net benefit. But you can still, like, there is probably like a happy medium. Like, you still need, like, AI is not going to replace engineers anytime soon. It's going to 10x good engineers, but it's probably going to hurt shitty engineers.
Oh, yeah. Yeah, exactly. And a lot of companies that are not engineering culture first, you're not necessarily seen as tech companies. They happen to depend on tech just because just about every company on earth nowadays depends on tech and having an engineering team in-house. I feel like those are the companies that are going to suffer more from this, It's really hard, even in today's market where, people are laying off engineers like crazy. Even today, it's still hard to get top engineering talent to kind of drive engineering culture properly in all these organizations. And they're going to be in trouble. I hopefully, it's we will manage as an industry, but the writing is on the wall in some way.
100%. Like, and if you actually, like, for me, I think if you follow the money, you get very close to the truth here. Like, because the people that are most bullish and most vocal about this, like, oh, AI, all code will be written by AI in the next 5 years. Almost everybody who makes those bold claims are either writing tools that are writing or in the AI ecosystem and directly benefit from it, or they are people who want to basically slash your entire engineering budget and not hire engineers.
Right. Yes. Yeah, exactly. One of these two visions is kind of crazy in the short term.
yeah, exactly. No, it's going to be an interesting ride. I mean, there is a scenario where the LMs and the tools will catch up. And by the time this disaster of a tornado will hit, the tools will be good enough to fix themselves. And that's a possible scenario. I guess we can't rule that out.
Yes.
And in case, fantastic. And maybe that was the right bet then.
Yeah, exactly. It's like that, the curve of, like, intelligent people making one decision and, like, the average. It's like there's going to be a decision that makes sense for the most intelligent and the least intelligent ones. And if that comes to become the truth, it's going to be interesting. Yes. But for now, I'd say from my perspective, I would be more careful than the immediate current state of affairs with AI it feels like we're not ready yet. You can sort of create demos where you build from scratch with AI and sort of have mini games and such, and they're maybe bug free mostly and they're safe. That's fine, but managing something bigger than that, it's just not real yet.
I would challenge that a little bit, because I think Cursor and the likes of are fantastic at doing busy work and just like refactoring busy work, right? Stuff that would take you forever to do, but it's not super complicated. You can describe it easily. Where they struggle is when things get too complicated, right? Because the context window is just not big enough to.
Yes.
It's not there, right? Which is why they just rather write new code than actually refactor the existing code because it's too expensive to read in all the context.
Yes, exactly. They're just not going to follow all the requirements, and maybe that will be surprising. You have to have strong tests for all the requirements and all that. Still takes a lot of work.
Yeah, and I mean, and not like the security is crazy. Like the amount of times like I've had like Cursor just like injecting and editing like a log file and managing dependencies. Like, whoa, hold on a second. Like, don't you just like change things? Like it's a crazy world. But I'm still bullish on the fact that this is going to be a net benefit, and there's no. I mean, I'm 100% sure there's a net benefit, right? It's just. Yeah. I think it's too naive, and there are too many people that are too naive about what things can do today. It's just like, yeah, they will be able to do at some point, but we're not there yet. Today, it's a tool that allows good engineers to be better, but not non-engineers to become engineers.
That's the other thing I'm wondering as well. What does the next generation of engineers, what does that look like, right? Because there's less need for the junior engineers, right? The AIs can do a lot of that, but now there's going to be maybe like a skills gap because those junior engineers will not become senior engineers, or maybe they're fine on the trajectory that maybe AI will get better faster than they would anyway. So maybe there's less need for senior engineers. I
would argue that there's less need for junior engineers, right? And I mean, this is a fantastic point, right? And I've done a lot of hiring over the years, and one of the things I have been surprised by, I mean, I'm getting old, but I'm hiring fresh grads these days. Like, I'm surprised by how many of them do not understand fundamentals anymore.
Oh, yeah. Yes.
Right?
Exactly.
Like, because the CS education, okay, there are the good schools like this, the Stanford of the world and all those. Of course, they have like world-class engineering schools. But for the bulk volume of engineering schools, like I've had like people coming out of a CS program, like you have to teach them how to use like Git, and it's like, what the hell have you been doing for the last 4 years?
Exactly. Right? Yeah, there's like so many abstraction levels that make things so much easier for us, the engineers, that we kind of forgot where we came from, and now that's a knowledge gap that is gonna affect people, I think.
Yeah, because like I mean, I would imagine we're like roughly the same age, and like we grew up using like Linux early on. Like you grew up learning a lot of those things by doing. And like I have no CS degree, but I've schooled CS people a lot because just I've been exposed to it for so long, right? You just learn lower level stuff by virtue of playing around with it, right? And that knowledge gap is very real today, and I think it's going to be 100x that in like 5-10 years, right? With these level abstractions. Yeah,
exactly. You're going to be building with React or like AI agents and so on, and have no idea how HTML works or HTTP and all that. So like, where
like today,
is this industry going?
Whilst today we're like annoyed that newer graduates do not understand like the Linux kernel or whatever. Like that's going to be like move like 5 level abstraction further, and they're like, it's going to be so high level that the Linux kernel is like COBOL to us, essentially.
Right. Yeah. Exactly. Right? Yes. Because you could argue the previous generation are complaining that we don't know how punch cards work or whatever.
Right. Exactly. Yeah. It's an interesting analogy. This has been super interesting. I think we covered a lot of good ground here, and I'm very happy about what we got covered. So thank you so much for coming on the show. Before we wrap, are there any closing notes, any shout outs you want to do? People want to learn more about Earthly or so on?
Yeah, well, thank you for having me. And yeah, if you're interested in improving your engineering excellence, your engineering standards, or managing SDLC at scale in your organization, check out earthly.dev, DEV. And yeah, hit me up. I love to talk to you. So
Awesome.
many thanks, Victor.
Amazing. Perfect. Thanks so much again, Vlad. Have a good one. Talk soon.
All
Cheers.
right.